Assalamualaikum warahmatullahi wabarakatuh. Greetings and regards to our English teacher Mem Tina. We're from class 11C2 English group and we are here to present or explain about how did the Aurora happen. But before what, I will introduce our group member first. My name is Monica, who will be the moderator during the presentation. Then for the two presenters from our group, there is Salsa and Rio. Then the one edited this video, right? Okay, to shorten the time, let's head over to the presentation session. For Sasa, the floor is yours.
An aurora is a natural light display that shimmers in the sky. Colorful blue, red, yellow, green, and orange lights shift gently and change shape, like softly glowing curtains. Auroras are only visible at night and usually only appear in lower polar regions. Auroras are visible almost every night near the Arctic and Antarctic circles, which are about north and south of the equator. In the north is called Aurora borealis. In the south, it is called Aurora australis. The activity that creates auroras begins on the sun. The sun is a ball of superhot gas made up of electrically charged particles called ions. The ions, which continuously stream from the sun's surface, are called the solar wind. A solar wind approaches the Earth. It means the Earth's magnetic field. Without this magnetic field protecting the planet, the solar wind would blow away Earth's fragile atmosphere, preventing all life. Most of the solar wind is blocked by the magnetosphere and the ions force around the planet continue to travel further into the solar system. Although most of the solar wind is blocked by the magnetosphere, some of the ions become briefly trapped in ring shape holding areas around the planet. These areas in a region of the atmosphere called the ionosphere are centered around the Earth's geomagnetic poles. The magnetic poles mark the tidal axis of the Earth's magnetic field. In the ionosphere, the ions of the solar wind collide with atoms of oxygen and nitrogen from the Earth's atmosphere. The energy released during these collisions cause a colorful glowing halo around the poles. An aurora. Most auroras happen about 97 until 1,000 kilometers above the Earth's surface. The most active auroras happen when the solar wind is the strongest. The solar wind is usually fairly constant, but solar weather, the heating and cooling of different parts of the sun can change daily.
Solar weather is often measured in sunspots. Sunspots are the coldest part of the sun and appear as dark blobs on its white-hot surface. Solar flares and coronal mass ejection are associated with sunspots. Solar flare and coronal mass ejection are sudden extra bursts of energy in the solar wind. Sunspot activity is triggered over an 11-year cycle. Bright, consistent auroras are most visible during the height of sunspot activity. Some increased activity in the solar wind happens during equinox. These regular fluctuations are known as magnetic storm. Magnetic storm can lead to auroras being seen in the mid-latitudes during the time around the spring and autumnal equinoxes. Aurora has been visible as far as the Yucatan Peninsula in Mexico. Magnetic storm and active aurora can sometimes interfere with communication. They can disturb radio and radar signal. Intense magnetic storm can even disable communication satellite.
Well, thank you for both Salsa and Rio for the presentation. That was the presentation about how did the aura happen from our group. As a moderator, I apologize if there are any mistakes or leak in its presentation. And also thank you for your attention. We're class 11 since 2 English group step down. Wassalamualaikum warahmatullahi wabarakatuh.